Hello. Today I will talk about Solar Testing Toolkit, a platform that helps banks and fintech companies significantly speed up the testing process, reducing the number of manual operations and thereby minimizing risks in productive systems. Solar Testing Toolkit is mainly used for testing processing systems, but any system providing an API can act as a testable one. All test scenarios are configured and managed via the web interface, so no additional software installation is required for employees. The platform supports various types of testing: functional, performance, regression, and integration testing, which allows you to meet all the needs of a QA team with a single solution. A separate area of application is the responder module. It allows the system to automatically respond to the corresponding incoming messages without additional running of test scenarios. For example, Responder can be used for testing ISO 8583 protocol and 3D secure authentication. Thus, comprehensive testing of the acquirer's operation can be conducted without the involvement of third-party systems, as Responder can emulate the operation of ACS, directory server, and the payment scheme. Solar Testing Toolkit is a modular platform. The slide presents key auxiliary modules. Solar Air is a user web interface for working with tests. Solar User Management is responsible for managing access to various tabs, forms, and actions depending on the user's group. Solar Reporting allows generating reports on the results of test scenario execution, projects, execution plans, and etc. Solar Bridge is an API through which the platform integrates with other systems. Having its own API allows the execution of test scenarios not only through the user interface, but also automatically after a new product version is released within CI/CD processes or on a schedule. This significantly reduces the impact of human error and ensures early defect detection. Additionally, you can configure email notifications with the results of test scenario executions in PDF report format. Various adapters are used to connect Solar Testing Toolkit to the system under test, including HTTP adapter for testing REST and SOAP requests, JDBC adapter for executing SQL queries to databases, batch adapter for exporting and importing various files, enabling testing of, for example, clearing files or any reporting. ISO 8583 adapter for integration with various payment schemes, POS controllers, and host-to-host interfaces. Also, we support the requirements of upcoming IPS releases and update the dialects in a timely manner. In addition to those listed on the previous slide, additional adapters for POS terminals, ATM controllers, and other specialized protocols are also available, allowing for virtually any integration of processing systems. The main value of Solar Testing Toolkit is the ability to build deep automated tests that reflect the full life cycle of operations and products. By combining several different channels for interaction with the system under test, you can, within a single test scenario, for example, issue a card, perform a transaction on it, generate a clearing file, and upload it to the processing solution with subsequent verification of the transaction's success. Thus, the solution allows testing not only individual operations but also end-to-end business processes. The platform supports both black box and white box testing, for example, through connecting to a database for analyzing the system's intermediate state. The product has many features to speed up the creation and maintenance of tests, namely copying, exporting, importing scenarios and projects, as well as templates and parameter sets. This is especially useful for regression testing, when there are many scenarios and they are regularly updated. Additionally, the platform includes a set of cryptographic tools available from scenarios through contextual functions. For example, a function for encrypting a PIN block for performing transactions. The platform supports working with multiple test environments, allowing different teams to work simultaneously without interfering with each other. Creating test scenarios does not require programming skills, which also allows you to involve analysts and business team specialists in testing. A flexible validation system allows configuring checks at any step of the scenario. You can validate both incoming messages and the content of variables, choosing the necessary comparison methods. At the same time, the ability to transfer context between steps of the same scenario is also supported. Testing Toolkit operates as a server solution with the user connecting through a web interface. The Solar platform does not require the installation of any additional paid software. The platform's architecture is flexible. It can be deployed in the cloud or on Linux servers, depending on your infrastructure. We are also open to discussing the provision of a service based on the SaaS model. Next, let's look at a simplified diagram of the main objects in Solar Testing Toolkit. We'll start with the base configuration. To work simultaneously with multiple test environments, the environment object is used. With a single set of tests, you can run scenarios on any environment, for example, on a dev, pre-prod, or load environment, without migrating scenarios or switching configurations. Channels and dialects describe ways of interacting with external systems, including parameters for each environment. Let's look at what a channel looks like on the interface. A channel is a logical interface for interacting with a specific external system. In the settings of each channel, the type of dialect is specified, that is, the format of the messages it works with. The available dialects are listed in the drop-down list. Below, there is a form with additional settings and a list of environments for which this channel can be used. Connection parameters are specified for each environment, for example, the connection URL. By selecting the environment when running the scenario, you automatically select the correct set of connections, which reduces the number of errors and speeds up testing. This concludes the objects responsible for the base configuration of the system. Next, let's look at the main objects used to build test coverage. The first such object is the test scenario. Each test scenario consists of test steps. Each step is a single action, for example, sending or receiving a message through a specific channel. Test scenarios are grouped into projects, directories for structuring test coverage. Execution plans are used for mass test runs. They allow automatically run a large number of scenarios from different projects under specified conditions, for example, for regression testing or checking a specific product. Let's look at the last category of objects that help speed up and simplify the process of creating test coverage. Each step can either directly interact with the system under test through a channel or use a template. A template is a convenient way to combine repeating steps into a single reusable structure with incoming and outgoing parameters, similar to a function in programming. Steps in a template can both use a channel to send messages and call other templates. That is, templates can be nested. The main advantage of using templates is centralized updating. If the logic or message format changes, it's enough to change the template. All scenarios using it are updated automatically. As a result, after the initial setup of basic templates, further expansion, updating, and deepening of test coverage proceed significantly faster and require much less efforts. Another object is parameter sets. This is a centralized storage of test data, which the scenario accesses through variable calls. Parameter sets can be created manually or using a JDBC channel by writing a select query, thereby automating the process. Let's look at what a test scenario looks like in the testing toolkit. At the top, there is general information about the scenario. In the upper right corner, there are the main control actions: running the scenario, export, transfer between projects, copying, and editing. The steps of the scenario are divided into main and final. Final steps are always executed, even if the test ended with an error, which allows the system to be returned to its original state. For example, in the first step of the scenario, we switch the bank date to the current one, and in the final step, we automatically return it back. Below, there is the history of scenario executions. Here you can see who, when, and on what environment executed this test, which allows tracking the dynamics of changes. Within this scenario, the toolkit emulates two external parties: the system initiating client onboarding and card issuance, as well as Visa payment scheme, sending an authorization request in ISO 8583 format to the processing solution. The scenario ends with a check of the form transaction using a database query. The onboarding step is presented as an HTTP request. Request fields can be filled in different ways, including using variables saved in the previous test steps or using various contextual functions to generate values. The toolkit sends the request, receives the response, and automatically performs all checks specified in the step. Let's look at the result of this step execution. Here, the outgoing and incoming messages are displayed in XML and JSON formats, as well as the results of the incoming message check. All checks were successful. The next step is topping up the card. It is built based on a channel with the ISO 8583 Visa dialect. According to the selected dialect at the step, the corresponding fields are available, which can be selected from the drop-down list. The scenario sends an authorization message 0100, receives a response 0110 from the processing solution, and checks key parameters. For example, that in the 39th field, the response code is 00. In the result of this step execution, you can see the received authorization message, the formed response, and the status of the check's execution. The last step is checking the transaction in the database. A select query is executed through the JDBC channel and selects the created authorization by the RRN identifier obtained in the previous step. Then, a table comparison is used to match the actual values with the expected ones. In the result of the step execution, it is visible that after executing the SQL query, we received data on one payment as well as the result of the table comparison. The obtained table completely matches the expected one. Let's talk about performance testing. An additional module connected to the system is used, and the load does not require deploying a separate application. The configuration of performance tests is very similar to functional scenarios. A performance test scenario can also be quite complex. However, compared to a project designed for functional testing, a load project is carried out in stages. A stage is a time period during which all project scenarios are executed simultaneously and the results are saved with a set frequency, forming statistics. This approach allows managing the load, for example, gradually increasing it and modeling different operating modes. For each scenario, its own load profile is set. You can define limits on TPS, the number of scenarios repeats, and the number of threads at each stage. The profile can be based on productive data, allowing for the most accurate reproduction of the system's real behavior. This concludes the overview. Thank you for your attention to this presentation. Solar Testing Toolkit is a tool that allows testing processing solutions and integrations not manually by checklist, but as managed, repeatable scenarios, which speeds up testing, reduces change risks, and improves the quality and stability of releases. We will be happy to answer your questions and discuss how Solar Testing Toolkit can assist in your project.